Okay, so here we are in 512, solving equations by factoring. And this is going to be really the first section where you use all of the factoring techniques that we've been learning earlier in chapter 5. So today we're going to learn how to solve polynomial equations by factoring. Now before we get into solving equations, we have to understand what's called the zero product property, which is what all of what we do in section 512 is pretty much based on. And it says this: for all real numbers a and b, ab equals 0 if and only if a equals 0 or b equals 0. And what this if and only if means is it's a double implication, meaning if we have a times b equaling 0, then it must be true that either a equals 0 or b equals 0. And then the other direction is true as well. If we start over here on the right side and say that a equals 0 or b equals 0, then it must be true that a times b has to equal 0. So here are the steps to solve a polynomial equation, and I'll keep reminding you of these 4 steps as we solve equations. Step 1 is to get one side of the equation to equal 0, to move everything to one side of the equal sign. Step 2 is to factor the non-zero side of the equal sign. Step 3, use this zero product property that we just discussed on the previous slide. And step 4, set both factors equal to 0 and solve the equations. Okay, let's start with this pretty simple polynomial equation. 3x plus 4 times 2x minus 1 equals 0. Now this one's tailor-made for us to use this zero product property, because the zero product property says this. If you can read it there, it says ab equals 0 if and only if a equals 0 or b equals 0. So what we have here, gentlemen, is the product of 3x plus 4 and 2x minus 1 equaling 0. So if you have two things multiplied to equal 0, which is what we have here, it must be true that one of the factors, either 3x plus 4 equals 0, or the other factor, 2x minus 1, equals 0. That's what this zero product property says. So solve both of these equations. We'll subtract 4 from both sides here and divide by 3. And one of my solutions is going to be negative 4/3. Solving the other equation, we'll add 1 to both sides and divide both sides by 2. And my other solution will be x equals 1/2. So my two solutions are negative 4/3 and 1/2. This is one in which we're going to have to go through our 4 steps, highlighted right over here to the right. First, get one side of the equation to equal 0. Or in other words, move everything to one side of the equal sign. Now when you decide which side to move everything to, you want your highest degree term to have a positive coefficient. So we're going to move this y over to the left. And the way we move the y over to the left is we're going to subtract y from both sides. And look at the resulting equation. When you subtract y from both sides, I get 0 on the right. On the left side, I'll make sure I'll put my terms in decreasing order according to the degree of the terms. And I get 3y squared minus y minus 10. That's step 1. Step 2, this is where all your practice with factoring comes into play. Factor the non-zero side. So let's factor 3y squared minus y minus 10. There is no GCF, so let's just have at it. 3 is prime, so it's going to be 3y and 1y. I need my two numbers to multiply to give me negative 10, and they must have a product of the outside coefficients plus the product of the inside coefficients must equal negative 1. Now let's see what's going to work here. How about if I put a minus 2 here and a plus 5 here. Because the 3 times a negative 2 is negative 6. 5 times a 1 is 5. Add those two together and I get the negative 1, which is what we want. The third step is to use the zero product property on the non-zero side. So look at what we have here. We have 3y plus 5 times 1y minus 2 equaling 0. So the zero product property says that 3y plus 5 equals 0, or y minus 2 equals 0. Solve both of these equations. Here we would subtract 5 from both sides and then divide both sides by 3, and I get y equals negative 5/3. Here just add 2 to both sides and there's my second solution. So y equals 2 or y equals 5/3. Let's try this one. 10k cubed equals 5k squared. So should we move everything to the right or to the left? Now remember, you want the highest degree term to have a positive coefficient. So let's move the 5k squared over to the left. So I get 0 on the right, and I get 10k cubed minus 5k squared. Now I've got to factor that left-hand side. That's step 2. Now it looks like we've got a common factor. We should always look for a common factor first, and the GCF in this case is 5k squared. And you factor out that 5k squared, I'm going to be left with 2k minus 1. Use the zero product property on the non-zero side. So we'll look at step 3 and step 4, which says set both of those factors now equal to 0. So 5k squared equals 0, or 2k minus 1 equals 0. Now I haven't really solved an equation like this before. But what we can do is just divide both sides by 0, and I get k squared equals 0. And the only real number that when squared will yield 0 is 0. So that's one of my solutions. With the other equation to solve for k, add 1 to both sides and divide both sides by 2. And you get 2k is equal to, you get k is equal to 1/2. So there are your two solutions. K equals 0, k equals 1/2. Look at this one. So this is going to involve another layer, which you're going to see here momentarily. First step, get one side to equal 0. So it looks like it's going to be in our best interest to move everything over to the left. So let me add 27 to both sides. So that leaves me on the left side with 12t squared minus 36t plus 27. Now, as we've always said, your first thing to look for when you're asked to factor a polynomial is a GCF, which in this case is 3. Leaving me on the inside with 4t squared minus 12t plus 9. Now take a good look at that 4t squared minus 12t plus 9. That's a special case of factoring. That's one of our perfect square trinomials. 4t squared is the square of 2t. 9 is the square of 3. If you multiply 2t and 3, you get 6t. If you double 6t, you get 12t. So this is a perfect square trinomial, meaning it is the square of a binomial. In particular, it's the square of 2t minus 3. Now, using the principle of, or property of zero product, step 3, really you've got 3 factors here. You've got 3, you've got 2t minus 3, and you've got another 2t minus 3. So if I've got 3 factors multiplied to equal 0, it must be true that one of them is going to equal 0. Now we know 3 is never going to equal 0, so don't worry about setting 3 equal to 0. I'll set 2t minus 3 equal to 0, but there's no sense in setting 2t minus 3 equals 0 twice, so just do it once. Solve this equation for t by adding 3 to both sides and then dividing both sides by 2, and I get t equals 3/2. So only one solution here for this polynomial equation. So look at this one. This is a quartic. Remember, we've talked about the word quartic means degree 4. So let's move everything over to the left. Subtract 13q squared. It gives me 0 on the right, q to the 4th minus 13q squared plus 36 on the left. Now because it's a quartic, when we factor the left-hand side, these will both be q squared. I'm looking for two numbers whose product is equal to 36 and their sum is equal to negative 13. Those numbers would be minus 9 and minus 4. Now if you look at those two binomials, those are both factorable further. The q squared minus 9 is a difference of squares. Q plus 3, q minus 3. The q squared minus 4 is a difference of squares. Q plus 2, q minus 2. Now look, we've got the product of 4 factors equaling 0. Now I know the principle of zero product says set both factors equal to 0, but I've got 4. So set all 4 equal to 0. Q plus 3 equals 0. Or q minus 3 equals 0. Or q plus 2 equals 0. Or q minus 2 equals 0. And that's going to give me 4 solutions. Here I'll get q equals negative 3. Here I'll get q equals positive 3. Here I'll get q equals negative 2. And here we get q equals positive 2. So 4 solutions to that quartic equation. Now this one, it looks like you're already done because you've got the left-hand side factored, but because I've got an 18 over here, we're not quite ready to go. Here's what we need to do. Get one side to equal 0. So let's subtract the 18 over to the left-hand side. So now, what we need to do is clean up the left-hand side by foiling the 2m minus 1 and the m minus 3. So let's do that. FOIL. Product of the first terms is 2m squared. Product of the outside terms is minus 6m. Product of the inside terms is minus 1m. So when we combine, I get minus 7m. And then the product of the last terms is plus 3. And then I still have this minus 18. Now you're going to collect these like terms, and I get 2m squared minus 7m minus 15. So now we're ready for step 2. We want to factor the non-zero side. So 2 is prime, so it's got to be 2m and m. Looking for two numbers that multiply to give me negative 15. And then when we take the outside numbers and multiply them, take the inside numbers and multiply them, we're looking to get negative 7. Let's see what works here. I believe it's going to be minus 5 here and plus 3 here. Because negative 5 times 2 is negative 10. 3 times this 1 is 3. Add them together and we get negative 7. So the zero product property says that 2m plus 3 equals 0, or m minus 5 equals 0. So both of these equations, subtract 3, divide by 2. Here I get m equals negative 3/2. Here we add 5, and I get m equals 5. Two solutions, negative 3/2 and positive 5.